answer is one comparison. Yeah. But only small 2 or 3, as I remember in your class. Yeah, I haven't completed. Yeah. So 2 or 3 students give me the correct answer. Most other students give me 2 or 3 as the answer. The first reason, they did one precious comparison on X5 and X6. That comparison is not necessary. Because the reason you do that comparison, you want to find the maximum, right? Yeah. One comparison, you can find the max. So you feel more comfortable by knowing that max element. Yeah. Actually, think about if you take away here, if you take away X5, X6, in the remaining 4, can you say the remaining 4 elements, they have no chance to be max, right? Yeah. None of the remaining 4 could be max. And this information, you don't need that comparison, right? You don't need to do comparison between X5, X6 to tell you none of the element in the first 4 could be max. So if you pick anyone in the first 4, already not the max. You already know that. So you just pick 2 from the first 4. You know, most just pick X1 and X2. Then you do one comparison between them. Okay, yeah. So one comparison. You know, one is larger and the other is smaller. Yeah, let's assume X1 less than X2. Yeah, then X2 cannot be the minimum, right? Yeah. But you already know X2 cannot be the max, right? Yeah. Then that's your solution. That's simple. Okay? Yeah. We did. Yeah. So the first question I give you, I didn't give you any condition that you need 3 comparisons. Yeah. Because no information given. So you select 3 of the elements, then you sort it with 3 comparisons. Then you use the median of the 3 to give you the solution. The second time, I give you the condition. What's that condition? Yeah. One of the element cannot be the maximum, right? I'll give you that condition. What's that? Right, yeah. I give you one of the elements cannot be the maximum. I'll give you that information. Then you need to use 2 comparisons. So one better. This time, I'll give you a little more information. Okay. The maximum belongs to one of the 2 elements, but you do not really need to find which of the 2 is the maximum. Okay. So these 3 questions. All right. Yeah. All right. So that's the first question. Second one. Yeah. Second one, the answer is 110. 110 comparisons. Yeah. Most students, yeah, quite some, yeah, at least 1/2. The students gave me 113. Okay, yeah. All right, 113. Yeah. So you use 124 minus 10, right? Yeah. So then, you know, for some reason, minus another 1. Yeah. Yeah, actually, yeah. Yeah. Yeah, but quite some students got this one. Yeah. Because think about, with a given condition, So the given condition, the information, you already, you know the results of 4 comparisons, right? Yeah. So, you know, the given condition gives you the results of 4 comparisons. That means you can save 4 comparisons from the given condition. Okay? Yeah. Without given condition. Okay? Without given. Without the given condition, you need, you know, based on our homework. That's our homework result, right? So you just do subtraction, top 10. Top 10, you minus 10. Yeah, so that's our homework question. So you need 114 comparisons. But after that, you need to add condition back. Add condition back because you can save 4, right? Yeah. So you get 110 comparisons. Yeah. So the second, not very hard. Yeah. You just, you know, first you need to connect to our homework, that question. Yeah. So then, but you need to, and this saving way we used in our homework assignment, right? Yeah. We have 2 questions. We use this saving idea. Okay. Yeah. So not new. So the first 2 questions should not be too hard. Okay. The first 2 questions. Yeah. All right. Then the remaining 3 pretty hard. All right. The remaining 3 pretty hard. You just try your best. Yeah. Try your best to earn partial credit. No, because you need to do some challenging questions. Right? Yeah. That's reasonable. So, all right. Number 3, yeah. Number 3, yeah. All right. First, give you the answer. Answer 8 comparisons. Yeah. Many students give me the correct answer, but I look at their solution, not quite right. Not quite right. Yeah. I look at the details, step by step. Yeah. Yeah. Some problem. Yeah. Right. Yeah. So in my solution file, so I will post that solution file after sometime this afternoon. Okay, afternoon or tonight. Yeah. So I will post that. Yeah. So I will post that solution file. Yeah. You know, pretty long. Yeah. Because this question I gave 3 solutions. I give 3 solutions. Yeah. 3 solutions. Yeah. First 2 I call the weak solutions. The last one, strong solution. So what's that weak solution? Strong solution. Yeah. Weak solution, not as good as the strong solution, right? Yeah. So actually, most of you did this weak version. Okay. For weak solution, use 9 comparisons. Because not the best solution, right? So I call it a weak solution. Okay. Then strong solution. Then, you know, that's the best solution. 8 comparisons. Yeah. And weak solution, you can 3 points. Not a full credit. Okay. Yeah. Not full credit. What's wrong? Oh, so here, annoying. Yeah. Yeah. Because I do screen recording, so that, yeah. Only strong solution you can get a full credit. Okay. Yeah. 1 point off, weak solution. All right. So why those students did this weak solution? Most of the common problem is this. They use the tournament method. Okay. Yeah. Weak solution, I'll give you 2. Yeah. The first weak solution, most students did that tournament method. Yeah. All right, so X1, X2, yeah. Winner, yeah, let's say X2. Okay, yeah. X3, X4. Sorry, 4 here. Yeah. Winner X4. Yeah. X5, X6. Winner X6. All right. Then another round, winner, let's say X4. Right? Yeah. So comparison 1, 2, 3, 4. The last one, the maximum. Okay. Yeah, let's say X4. No, not X6. In the last comparison, you want to make X4 the winner because that corresponds to the worst case. Worst case. If you make X6 the winner, that's not the worst case. Okay. Yeah. Because we always focus on the worst case, right? Yeah. So not worst case. All right. How do you see that? Right? You may ask, how do you see that? Yeah. Look at the direct losers. So here there is a, important concept or direct. Look at direct losers. Direct losers, let's look at these two cases. If X4 is the winner, X6 is the winner, their direct losers are different. X4 is the winner. What are direct losers of X4? X4 beats X3, beats X2. X2 is the direct loser. X4 beats X2 directly. X4 beats X3 directly. X4 also beat X6 directly. So there are 3 elements as the direct loser to X4. But if you use X6, X6 beats only 2 direct losers, beats X4 directly and beats X5 directly. But other elements, not direct loser. All right. Yeah. Why the direct loser matters? Because when you consider second largest, you only look at direct losers, right? Yeah. Because only direct loser has a chance to be the second largest. Indirect loser, no chance to be the second largest. So direct losers, the candidates for second largest. So the more candidates for second largest, the more comparisons you need to do, right? So that's the worst case, right? So for that reason, we pick X4 as the winner. So we have to do more comparisons for the worst case. Yeah, yeah, because you need to pick the worst case to work. All right, now, based on this, let's do this second largest. Yeah, because we already get the largest. X4 is the max. We know. Second largest, we need 2 more comparisons, right? Yeah, so we know that. The number of elements minus 1. So we need 2 more comparisons. All right. After that, then we do third largest. All right. Yeah. The last round, we do third largest. Third largest, we need to look at the candidate, direct loser to second largest, right? Yeah. So which element, which of the 3 should we use as the winner of the second largest? Then it's important, right? Which element? Because we need to pick the worst case. That's the place most of the students, they couldn't get it correct. Yeah. Yeah. So here you need to pick, yeah, in this, when you pick X2, you look at the direct loser. Yeah, more direct loser. Yeah. Yeah. So here, X2 or X3, either one is fine. But you should not pick X6. If you pick X6, only 2 direct losers to X6. 2 direct losers. Yeah. So you should not pick second largest as X6. Yeah. X5 and X6. Yeah, because X6 beat another one, right? Yeah, so only 2. Yeah. Small number. But if you pick X2 or X3, yeah, let's say we pick X2 as the winner of the second round, okay, for the second largest, X2. If you pick X2, the candidate becomes, yeah, candidates, okay, all right. X1 is the candidate, right? X1 direct loser to X, yeah. Then X2 also beat the other 2, right? Yeah. X2 beat X3 and X2 beat X6 in the second round. So you have 3 candidates for the third largest. 3 candidates, you need to find the largest one. You need 2 more comparisons, right? Yeah, 3 elements. You need to get largest, so you need 2 more comparison. Okay, all right. After 3 rounds, the total 5. First round 5 tournament. Second round 2. Third round 2. Total you have 9 comparisons. Right? That's the weak solution. All right. Yeah. If you can do this, you get 3 points. Yeah. Because it's a weak solution, not the best one. Okay, not the best one. All right. But large number of students, the third round, they give me 1. Okay, they give me 1. Yeah, because they only select 2 candidates. Remember, 3 round. For the worst case, you should have 3 candidates, not 2 candidates. Okay, so if they give me 1, yeah, because they happen to give me the correct answer in comparison, right? But they use the wrong method. Okay, the method is wrong, the answer is correct. Yeah, but still, we know the method is more important, right? The method is more important than the answer. Yeah. So in that case, I give 2 points. Yeah, not 3 points, 2 points. Okay, yeah. So if you do perfect to give me weak solution, you get 3 points. But now you didn't do perfect, right? Slightly short. In your third round, you didn't do it right. Third round. So I took 1 point for your third round. All right, so you get 2 points. Yeah. So many students did in this way. Yeah. Also pretty good, right? Yeah. But the strong version, very complicated. Yeah. Very complicated. Yeah. So I do not talk about that because here I do not have enough time. So I do not talk about the strong. I just post my solution in the solution file. You study by yourself. Okay. Yeah. I draw diagram, yeah, pretty long, yeah. 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 Pretty complicated. Yeah. But you can target a weak solution, right? Yeah. So for the very hard questions, you just try to earn as many points as you can. You do not have to be perfect. Okay. Yeah. Try your best. Yeah. Yeah. So this weak solution way, pretty good. Okay. All right. But there is another much easier weak solution I give you. So here I just tell you the idea. The second weak solution. All right. 6 elements you split into 2 subfiles. First 3, last 3. Okay. First 3 elements, last 3. two groups. Okay. First three elements, can you sort it? Sort the first three elements. How many comparisons do you need? Sort three-element array. Not many. Worst case. Do not give me the best case, all right? Worst case to sort. Three. Yeah. So when we work on our question like this, always work on the worst case.
If we're dealing with an array of three elements, then you have to specify the permutation of the array that you're trying to sort. Like you gotta like, you know, like this, but that is to say like what border are you trying to sort it in, and then you have to compare each, like you got to determine the number of comparisons. Like the fewer comparisons you do, the more efficient of an algorithm you have for sorting.
Yeah, don't need. All right. Yeah, because you solve three-element array. It's too simple. Yeah, you just tell me you use three comparison. You can sort it. Then you assume the specific order: x1 less than x2 than x3. Yeah, you do not need to consider all the permutations. Yeah, because we only need one special case, right? Yeah, one of the special case. You just assume x1 less than x2 less than x3. That's enough. Okay, so you do not need to do too much work. Okay, yeah. So you tell me sort it, because everybody knows how to sort three-element array, right? You don't need to give me the detail. Okay, we assume we can do it easily. Yeah. All right. Yeah. So that part. After that, you have two ordered arrays. Yeah, let me write this way. Yeah. You can make assumption. This assumption has no problem. Yeah. Yeah. No problem. All right. X6, X5, X4. All right. Remember, we used 6 comparisons, right? Yeah. Remaining, if we target the weak solution, we have 3 more to go, right? Yeah. So 3 more, we can get third largest, all right? Because number 7, you compare x3 and x6, you get a max, right? Yeah, 1 comparison, you get a max, all right? And here you can assume x3 less than x6. Yeah, because symmetric, right? Yeah. Either case, similar situation. You can make assumption. Okay, x3 then x6. So x6 is the largest. So x6 is gone. Who is the second largest? Okay. You do one comparison between x3 and x5. The winner is the second largest, right? Yeah, winner. Yeah. So the winner second largest. All right. Yeah. So this is number 8, right? Comparison number 8. Yeah. Because this is comparison number 7. Okay. All right. The last comparison, the loser of the second comparison, you compare it to the next available. 2 cases, right? 2 cases. Okay. So the last 9, the number 9, you can get the third largest. This is the second weak solution. Much easier, right? Yeah, this way much easier. Okay. Yeah. So this solution easier than the first weak solution. Okay. Yeah. Yeah. All right. So yeah. So this is a nice solution because you can earn 3 points. That's pretty good. Yeah. 3 points. Yeah. Yeah. But a strong solution. Yeah. Extremely complicated. Yeah. Yeah. Very complicated. Yeah. But there is one. Yeah. You can do it. Yeah. It's hard, but you can do it. Okay. Yeah. All right. So that's the question number 3. Yeah. Number 4. Oh, number 4 actually not too hard. Yeah. Not that hard. Actually, I feel number 4 is easier than number 3. Easier than number 3. Yeah. the answer 14. 14 comparisons. Because this question, remember we have a similar question in our homework assignment, right? Yeah. I only change the number. You look at last question in our homework assignment number 1. In that one, we have 8 elements. Then you solve this problem. Here, I only change 8 to 10. Okay, I added two elements. You use the same way to do it. Okay, same method, same idea. Yeah, but when you go from 8 to 10, this place you need to apply one formula. So I find the second largest element. Yeah. Some students, they search the web, they can find that formula. Yeah. Some students, yeah, because in this case, you may want to search the web to find the formula. Yeah. So the only change is you need to apply the formula. Find the second largest element. Yeah. Yeah. I saw several students, they wrote that formula. Okay. So here, let me give you the formula. And number of elements plus ceiling function of log base 2 of n minus 2. This formula. Okay. Yeah. All right. Yeah. That's the formula finding the second largest. Yeah. Yeah. In class, I didn't talk about this formula. Yeah. But later in module 4, I will explain why we can get this formula. We apply tournament method. Yeah. So we can derive this formula. Yeah. In module 4, I will talk about it. Yeah. Yeah. But this question, because you can search the web, right? If you know, yeah. When you need to do something, yeah. When you need to do something, it's online test, right? It's online test. You can use the internet. Okay. Yeah. I didn't say you cannot use the internet. All right. So you can use the web search, right? Yeah. So you find this formula, then you plug in, but use n equals 5, not 10. Okay. Yeah. So with, yeah, I saw one student use n equals 10, n equals 5. Okay, not 10. Because why 5? We have 2 groups. Remember, winners group, losers group. So you split x2, x1, x4, x3, x6, x5, x8, x7, x10, x9. So winners group 5, losers group also 5. So you apply this formula on the winners group first time, losers group second time. Okay, but you only need to just do one of the 2 cases because it's symmetric. Okay, you just double. Okay, yeah. After you get the number, you double it. Right? All right. So you apply it on the winners group. Yeah. Because after this formula, you get both max and the second largest. This one, you get the max first and plus second largest. Not just the only second largest. You get both. Okay, you get both. So you get both after 5 plus log base 2 of 5 minus 2. You get a 6. So after you use 6 comparisons, you find both max and second largest. Max is the global max, right? But second largest is the local largest. Remember in our homework assignment, the second largest, you need to do one more comparison. to get a global second largest, right? One more comparison. So you need to add one more for global second largest. Okay. So you need 7, okay? Yeah, 7. 7 as the subtotal, right? Subtotal. Yeah. But for the losers group, you do the same thing, another 7. Yeah. So you double that 7. So you get a 14. 14 as the solution. This is total. Okay. Yeah. So that's question number 4. Yeah. So I feel for question number 4, it should be relatively easier than number 3. Yeah. The only thing, yeah, because the general idea, you just borrow that idea from our homework assignment, the last question. Yeah. Question number 25, the last one. Yeah. You borrow the same idea, all right? Yeah. The only thing you need to do, you need to find the formula, all right? Second largest, yeah. So you find this formula, okay? So you can use online search, okay? Because I didn't say, when you do it in this classroom, I do not allow you to do the online search, okay? Yeah. So in the midterm, in the test, when you sit here, so I do not allow you to online search. Yeah. So then you cannot. Yeah. But at home, if it's online, yeah. If it's online, you can always use online search. All right. Yeah. Yeah. Always allowed. Yeah. Yeah. That's the main difference. Okay. That's the main difference. Yeah. 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 That's number 4. Yeah. Number 5, last question. Yeah. Oh, yeah, here. Yeah. Okay. Yeah. Yeah. All right. The last question, the hardest. Yeah. So definitely it's hardest. Yeah. All right. The answer. Yeah. Yeah. As I remember, 10. Yeah. As I remember, 10 comparisons. Yeah. Yeah. Let me check here. All right. Yeah. 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 All right. So this side. Yeah. All right. Yeah. So let me double check. This side. Yeah. Yeah. I have the solution. Yeah. Yeah. So in my recording, recording machine. Yeah. Let me double check it. Yeah. The last one. Yeah. That's very hard. Yeah. All right. Very hard. Answer. Yeah. 12. Sorry. Not 10. 12. All right. Yeah. Okay. That many. Yeah. But I noticed many students give me the correct answer. Yeah. But I look at their solution, some problems. Yeah. Answer 12 comparisons. Yeah. All right. The main problem, actually, I agree with several students I noticed. There is the problem is quite common. The problem is quite common. Yeah. All right. Yeah. Let me talk about the idea. Yeah. Yeah. So they split. Okay. Yeah. So they split. Yeah. X2, X1, X4, X3. Yeah. 2 groups. You can split. Yeah. by the way, I say something, because one student always give me two versions. I want to say, because this information given never count these comparisons, all right? Gabriel, never count, okay? Because given that means you don't need to do anything, you already have it, right? Never count, okay? So, all right, so then you can save here four comparisons here, all right, because in the final you will have many similar questions, the style, okay, final similar questions. All right, you're right, this we have module 4. Module 4 actually, so you're right, because module 4 cover there are similar topics here, all right? Yes. Module 4 we learn merge sort. So we will use the merge sort to solve these problems. So that's why we based on the merge sort. In 2 we will learn insertion sort and merge sort in module 4. So we have many questions we need to use insertion sort and merge sort to solve. All right. That's why similar problem, but we use new methods. Okay. So that's why we have similar questions. But we have better methods to solve. So that's the reason we may have similar questions. All right. All right. So here. All right. So those many students, so they do this way. So they find max here, then find a minimum. Find a minimum. So actually very strange. Some students also find a max here, but some students also did a minimum here in the losers group. All right. But quite messy. Sometimes talking about the max, sometimes minimum, very confusing. Very confusing. Then they use X9 to compare with max, compare like that. Okay. Then, because when you do comparison, there are many cases, right? But they only talk about one case. Only talk about one case. That's not good. Okay. No. That's not good. So many students, they give me the correct answer. The answer very close to this 12 correct answer. Some 11, some 10, very close. But the method not quite right. So use X9. Then you do comparison, you assume X9 less than some number, then X9 less than the other number, then X9 is the solution. So we know X9 solution is just one of the cases. You have many other cases. Because other elements could be the solution. So they didn't talk about other cases, right? So here, the solution very complicated. But for the solution, because we have two first group, we have two groups. So we sort. We sort each group, sort losers group, sort winners group. The first step. We sort these two groups. Okay. That step with the given information, remember, we have given information. right? With the given information, we need 3 comparisons to sort. Yeah. We need 3 comparisons to sort. Yeah. 6 plus 3, 6 comparisons. Yeah. 6 comparisons, we get a 2 ordered arrays. Here. 2 ordered arrays. Yeah. Yeah. And here we can make assumption. Okay. Yeah. Yeah. Because we just need an ordered array. So you do not need to consider many possibilities. Yeah. We just pick a representative. Yeah. First, we know these 4 elements are sorted. Then we pick one representative. One representative. So no problem. One special case as the representative. Yeah. Here you can use one case to represent all. Yeah. Okay. Yeah. Yeah. But when you do comparison X9, you have many cases. You cannot just pick one of the cases. That's different. Okay. That's different. Yeah. Because X9 as the winner or loser cannot represent other cases. Here we pick one special case because this case can represent all the other cases. That's why we can use only one case to be the representative. Yeah. All right. So let's say after sorting, here, X1, X2. Oh, sorry. Yeah, here my writing incorrect. When we do sorting, yeah, it's not on winners group, not on losers group. Yeah, not that. Yeah. So you split first 4 and last 4. Okay. Yeah. First 4 you sort. Last 4 you sort. Yeah. Then you need 3 comparisons. 3 comparisons. First 4, last 4, you do the sorting. Okay. With the given condition, you need 3. Yeah. Without given condition, in our insertion sort, module 4 insertion sort, we will see we need 5 comparisons. Insertion sort, we will solve that. So actually, in module 4, we will solve many similar problems. Sort, how to sort, how to find the, second, third. That's the selection problem. That's our module 4 problem. Yeah. So because these 2 are our basic problems. So that's, although the similar big topics, but we use different techniques. Okay. We use different techniques. Yeah. So yeah. So I need to, thank you. You remind me of the problem. Yeah. Otherwise, before the midterm, we did sorting selection problem. Then after midterm, we cannot do sorting selection problem. So that's not good. Okay. Because sorting selection, that going through the whole semester. Sorting and the selection problem. So going through the whole semester. Yeah. But we use different methods. All right. We use different methods. Yeah. But the next time when I say that, so I will explain. Yeah. So when I say, so we not comprehensive next time, I will explain. Okay. Yeah, the methods. Yeah. All right. Yeah. So the last a few minutes, I just talk about a little more, so that I will finish. All right. 4 elements. We can make assumption. Yeah. Sorted. All right. Yeah. Then you have X9. Right. Yeah. But X9, let's put outside. Yeah. Then the next comparison. Well, then you can try many different ways. Yeah. I tried many ways. Yeah. But I felt, this comparison is the best. Yeah, based on my experiment. Okay. So number 7. we do this comparison. And there are two cases, but these two cases are not symmetric. So you need to discuss these two cases separately. Then use elimination method. Yeah. Use elimination method. Then fill in the details. Yeah. So that's very complicated. So if you read my solution, it may not be easy to understand you need to be very patient. I drew many diagrams, okay? I drew many figures. Oh, yeah. You need to be very patient, so very challenging, all right? Yeah, very challenging, yeah. Okay, all right. So so definitely I cannot go into through all the details, yeah. All right, yeah, just by the end of today, I will post that file. So when you have time, you can study, all right? Yeah, when you have time, study. But remember, in our final, the similar questions, we need to use insertion sort, merge sort to find the solution. Yeah, but I do not say it. In my question, I do not ask you to use which method to solve. You can use any method to solve, but yeah, using the idea, insertion sort, binary search, merge sort, these three methods, you can get the best solution. Yeah, that's the idea. Gabriel. Yeah. More. Okay. More questions in class. Yeah. Actually, yes. We will. In class. After insertion sort, I will give you 2 or 3 examples working through, and then after binary search and after merge sort, I will give you several questions. Yeah. In class. I will give every topic. After every topic, I'll give you 2 or 3 examples. Okay. Yeah. For example, I will talk about finding the second largest and the third largest. So I will do in class. Sort 5 elements array. I will do in class. 5. That's pretty complicated. And find the median of 5. I will do in class. Median of 5. Also pretty challenging. Yeah. So yeah, many examples in class. Yeah. Very challenging. Yeah. All right. Yeah. So then we, finish the midterm. So we can, from now on, we will focus on final. All right. Yeah. Everything from now on. So we will prepare for the final. Okay.